In this video, I'm going to be talking about pointers and references. So for those of you who are already familiar with this topic, you can easily skip this video. But with the others, you can follow along. And this is going to be a brief introduction to this topic. All right, so let's start with references. So what's a reference? A reference is nothing but an alias for an object. A reference by itself is not an object, it's just another name or another way to refer to a variable. So I've got an integer here. Um, I've set it to the value 34, and this is the way you define a reference to it. So you have the type, the base type, which is an integer, and then you have the ampersand followed by the variable name. So ri is a reference to the variable I. So wherever you use I, you can now use ri. Now a few things have to be borne in mind. One is that a reference can never be null. So when you create a reference, it has to be initialized. And once it is bound to a particular variable, you cannot rebind it to a different variable because it's another name for a specific variable. It's an alias for an object in memory. So you can't rebind it to a different object. So let's see what's being done here. So when I work on the reference, I'm actually trying to read the value of the actual object. So when I do a cout here, I'm actually going to get the value of I. And the same thing can, apply to writing into the variable as well. So I don't have to use the variable I to change its value. I can always use its reference, which is Ri. So when I carry out any operations on the reference, it's actually going to affect the actual variable. So I'm setting Ri to 344 here, and that in turn is going to actually change the value of I. So when I output I should see 344. So let's set a breakpoint here and then, run the program. So as you can see, Ri is 34 and I is 344. So that's the first cout statement where Ri takes the original value 34, and then we use Ri to modify I to 344, and then when we output I we should see 344, and so that's what we see here. I is 344. So that's how you use reference. Now let's go a little further. So here I've now declared a variable of type double, and I'm also declaring or setting up a reference to a constant double. So I can always create a reference to a const. So in other words, when I do this, I cannot use this reference to modify the target value. So in this case, dval cref is actually a reference to a constant double. So I cannot use this, and it's referring to dval. So I cannot use this reference variable to modify dval. And let's see when I uncomment this. So as you can see, the compiler flags an error here. So that's not going to be possible. But that being said, just the reference is a constant. So the target value, the actual target value dval is not a constant. So you can always modify dval directly, or you can use dval could have other references too, like what I've done here. Now I've created a dval ref, which is nothing but a reference to a double. So yeah, you can always have the space. So now using dval ref, I'm trying to modify dval. So I'm setting it to 77.34. So now when I output dval, I will see it being set to 77.34. Let's also output the constant reference. So let's see dval using the const reference. What's the const reference? I'm talking about this one. Like I said, it's bound to dval. So what we need to do is just output that. Let's see what we get for this. And all right, let me set a breakpoint here and let's run the code. So as you can see, dval is 77.34. That is the cout statement. So we have set dval ref to 77.34. So that's because we obviously can't modify it using this reference. So we have created another reference and we have modified 77.34, and we find that the target value dval has actually got modified. So that's why you see 77.34. Next, just for the sake of completeness, I'm also getting the value using this first reference dval cref, and so that's what is done here. And as you can see, dval cref also gives you the same value, 77.34. That's because dval cref is also bound to the same variable dval. So you can have, so this effectively shows you that you can have different references, so it's not that you're limited to just one reference. You can have a reference which is a reference to a const. You can have an ordinary reference. So in this case, the target variable as such is not really a const, it's just an ordinary double. But I can always create a reference to a const, or I can just create a regular reference. All that you need to remember is that you cannot use this to modify the target value. All right, let's keep moving on. Now let's come down to pointers. So for those of you who are familiar with pointers, pointers are nothing but addresses, pointers to addresses of variables. And how do you declare a pointer? So this is how you declare a pointer. So you got pi, which is a pointer to an integer, and it's always good to initialize a pointer to so that you don't, it doesn't end up with any junk values, because if you do not initialize a pointer and you forget to initialize it to a valid value, you cannot predict the behavior of your program. You might end up with a crash. So what have I done here? So I'm using the integer base type, and I'm saying pi is a pointer to an integer, and ival is just a regular integer. So it's not a pointer, it's a regular integer, and it stores the value 93. And now I'm initializing pointer pi. I'm setting pointer to the address of ival. So pi has the address of ival. Let's now try and use that pointer in an output statement. So like I said, you can use the dereference operator to get the value at that address. So it's actually value at this address, the value at the address stored in the pointer. So this pi stores the address of ival. So when the dereference operator is encountered, it actually goes to the address and then reads the contents of that address. So let's run this and see what happens. So as you can see, 3. All right, so that's what we expected. Now I can always use the pointer to modify the underlying variable, the underlying address. So that's what I've done here. So I'm using the indirection operator star pi, and I'm setting it to 101. And just to verify that the underlying variable has got modified, I'm outputting that. So let's try that as well. So as you can see, ival is now set to 101. So that's all good, pretty straightforward. Now comes a little more of involved coding. All right, so I'm now declaring a constant integer ci. So that would mean that I cannot change ci, I cannot modify it. Now pci is actually a pointer to a constant integer. So it helps to actually read it from right to left. So pci is a pointer, and it's a pointer to a constant integer. So, and I'm storing the address of that constant integer in pci. So what does that mean? It just means that I cannot use PCI to modify the value at that address. All right, but PCI itself can be modified. PCI can always tomorrow store the address of a different variable. But when it points to a constant integer, you cannot use this pointer to modify the underlying integer. You cannot use it to modify the target variable. Now let's go a little further down. So we got fval here, which is a float, and I'm declaring pfval, a pointer to a float. So once again, I'm declaring it to as a pointer to a constant float. So when I output that, what do I get? So let's set a breakpoint and see what happens. All right. So as you can see here, fval is set to 34.32. So that's this. Similarly, let's look at the previous statement. Ci is 39 star PCI. So we're using PCI, using the indirection operator on PCI, and we get Ci as 39. So that's all what we expected. So instead of actually outputting the target variable, we're using the pointer to um, get to the value. So now if you move further down, I've declared, so since fval is actually not a constant, it's just a regular float, I can always change it. So I've changed it to 84.33f. Now, I can't do this because once again, pf is a pointer to a constant float. So you cannot use that pointer to modify fval. And so that's why you see the compiler flagging an error here. So it says pfval is a pointer to a constant float. So the pointer as such cannot be used, but you can always modify the value because the value by itself is not constant. So you can directly modify the value. You just can't use the pointer to modify the value. So I have modified that, but then let me see. Once again, the pointer is still it's still pointing to fval. So even if I try and dereference pfval, I'm going to get the modified value. So let's check that out. So as you can see, so fval is in, and after that, what do? We modify it to 84.33. So when we output fval, we get 84.33, and then we use the pointer and then dereference that pointer. So we are using that constant, that pointer to a const, and we once again get 84.33. So this is pretty similar to, when it comes to constants, you just got to remember that if you're creating a pointer or reference to a constant, you can't really use those reference or pointers to modify the underlying value. So pointers are objects, and unlike references, pointers can be null. Pointers can be rebound to a different variable during during the lifetime of the program. Unlike references, they're not just bound only to one variable. They can be changed and rebound to a different variable. And clearly, pointers, as I said, pointers need not be initialized, but of course it's good to initialize pointers. And you can always set a pointer to be a null value. You can always set it to be null, or you can set it to be 0. A reference can never be null. All right, let's keep moving down and let's get into a little more of an involved topic. So references to pointers. So once again here I've declared a pointer to an integer, and this is an integer int12. I'm setting ptr to be the address of int12. Now how do I define a reference to a pointer? This is how I do it. So ref ptri is a reference to an integer pointer. So it's nothing but another name for that pointer. So that's all it is. It's just another name for this pointer. So instead of saying instead of using ptr1, you can always use ref ptri. Instead of using ptri, you can use ref ptri. So whatever syntax you use with ptri, you can use with ref ptri as well. So it's just a reference to a pointer, an alias for that pointer. So now you can use that reference to modify the underlying value, and that's what I've done here. So I've set ref ptri, and I'm using the indirection operator because it's reference to a pointer. So you got to dereference that pointer if you want to modify the underlying value. So I'm setting it to 389. It's initially 93, and we're going to be looking at the output, and then I'm using that to reference the pointer to modify the underlying value, and eventually I'm going to see whether the original value has been modified. That's int_val. So let's see what happens. Let me run this. So as you can see, int_val via the reference to pointer, that's the first statement. So it's 93. You got the pointer set up, then we're setting up the reference, and now through the reference we see that it is 93. And via the pointer, it's once again 93. Then we use the reference to the pointer and we set it to 389. And then when we output that final variable, the target variable, we see that the target variable has been modified. So that means that our reference to a pointer is actually referring to this underlying variable. So that's what we expected. So references are definitely, a very nifty feature in C++. They come in pretty useful in several cases, especially when you're passing around pointers, or instead of pointers, there are cases where you can actually use references. So the different scenarios and contexts where references can be used, pointers are definitely a very powerful mechanism, but they have to be used very carefully. So I would suggest for those of you who are new to it, play around with this code. This code is up on my repository. Play around with it and dig a little deeper into references and pointers. But these are the basics, and pretty much if you understand this, you should be good to go. At least you will have a working knowledge of references and pointers. Thank you, and I'll see you in the next video.